Hello students, how are you? Welcome to my channel Hallabool Physics. Okay, today's topic is resistance thermometer. You know, resistance thermometer is also known as platinum resistance thermometer. Now, why resistance thermometer is known as platinum resistance thermometer? Because resistance thermometer is made of platinum. It is made of platinum. Now again question arises here, why it is made of platinum? Yes, simple reason behind it here. It is made of platinum because platinum has high melting point. Platinum has high melting point. Now the question is arising here, what is the principle of a resistance thermometer? Okay, before discussing principle of a resistance thermometer, I want to discuss one statement in a class here. You know, if temperature increases, length of the wire also increases. If temperature increases, length of the wire also increases. If length increases, resistance also increases. As you know all students here, resistance is directly proportional to the length. Resistance is directly proportional to the length. So if temperature increases, length of the wire also increases. If length increases, resistance also increases. Resistance also increases. So what may be the principle of a resistance thermometer? It is based on the principle of change in resistance. Change in resistance with rise in temperature. With rise in temperature. Now again question arises here. What is the temperature range of a resistance thermometer? Yes, its temperature range is from minus 200 degrees Celsius to 1200 degrees Celsius. This is the temperature range of a resistance thermometer. Now one another question possible to arise now here. Where resistance thermometer we use? Yes, it is used to measure the temperature of motor engine. Okay, there are two possible conditions we have to discuss in a class. In a resistance thermometer, change in temperature may be small or may be large. Change in temperature may be small or may be large. A small change in temperature means linear range. A small change in temperature means linear range. A large change in temperature means non-linear range. Now what does it mean by this linear or non-linear range? Yes, we can understand with the help of these two diagrams here. Is the length of a wire. What is this one? Is the length of a wire is L. Here is also length of a wire is L. If change in temperature is small, then change in length will also be small, will be linear. There will be a straight line. But if change in temperature is large, change in length will also be large. It will bend into a arc. It will bend into a arc. Arc will be parabolic. So two things should be clear here. For a small change in temperature means a small change in length, and a small change in length means there will be linear range. Large change in temperature means large change in length, and large change in length means non-linear range. The shape may be parabolic. So two things we have to discuss in a class. First part we are taking here now for a small change in temperature, that is for the linear range. Now what is the principle of a resistance thermometer? Delta R is directly proportional to delta T. Delta R is directly proportional to delta T. Yes, you should know delta R is also directly proportional to R naught. Delta R is directly proportional to R naught. More original resistance, more will be the change in resistance. Original resistance, more will be the change in resistance. So delta R is directly R naught as well as directly delta T. Now, with the help of these two relations, we can say delta R is directly proportional to R naught delta T. Delta R is directly proportional to R naught delta T, or this delta R is equal to R naught alpha into delta T. So this is the coming relation on the board now. Delta R is equal to R naught. Don't be confused by these two symbols. Is a symbol of directly proportional, is a symbol of coefficient of linear expansion. This alpha may be positive or may be negative. This alpha may be positive or may be negative. Depends upon what we are using. Is it conductor or semiconductor? For conductor, alpha positive. For semiconductor, alpha negative. So first we will discuss for conductor, then after we will take for semiconductor. Okay, for conductor alpha positive, so alpha is equal to positive. You know, delta R is equal to R naught alpha into delta T, where alpha is positive. Now delta R is the change in resistance, and change in resistance, you know it here, final minus initial resistance. Final resistance is at T degrees Celsius, minus initial resistance is at 0 degrees Celsius, is equal to R naught into alpha into what is change in temperature is T minus 0. Change in temperature is T minus 0. So what is RT is equal to coming R naught plus R naught into alpha into T. RT is equal to R naught plus R naught alpha into T. Now this equation we can compare with the equation of a straight line. What is the equation of a straight line? Y is equal to C plus mx. Now, after comparing these two relations, it is clear here, if it is the equation of a straight line, is also the equation of a straight line. Now, comparing both relations, RT should be along y-axis in a graph. So whenever we draw the graph here, comparing both relations, after comparing it is clear, RT is along y-axis and this T is along x-axis. And what is slope is equal to R naught alpha. So we can take the graph now here. A graph will be in between RT versus T. RT is along y-axis and small t is along x-axis. RT is along y-axis, small t is along x-axis. Now we have to draw the straight line. How to draw the straight line? I discussed this part here in the previous lectures here. How to draw the straight line? By putting x is equal to 0, get the value of y, and by putting y is equal to 0, get the value of x. Here x means T and here y means RT. So RT is along y-axis and T is along x-axis. Put the value now here. Put the value x0, get the value of y. Put y is equal to 0, get the value of x. So we can take it now. If RT is equal to 0, the value of T will come minus 1 by alpha. Another here, if T is equal to 0, what is the value of RT will become equal to R naught. Now these data will be helpful to draw the straight line. Yes, put RT is equal to 0. The value of T is equal to minus 1 by alpha. Yes, if it is plus 1 by alpha will be towards the right hand side, but here it is minus, so it will be towards the left hand side. Minus 1 by alpha. Next, if T is equal to 0, RT is equal to R naught. So this is the value of RT is equal to R naught and it is non-zero. Now, picture is clear here. If T is equal to 0, RT is equal to R naught, and if RT is equal to 0, T is equal to minus 1 by alpha. Yes, picture is clear here. A straight line is passing through negative x-axis and positive y-axis. So this is the straight line. Passing through negative x-axis and positive y-axis. And what will be the straight line equation? RT will be equal to R naught into 1 plus alpha T. RT is equal to R naught into 1 plus alpha T. What is the slope of that straight line? Yes, comparing both relations. After comparing, it is clear here. M is equal to R naught alpha, and what is slope here? So slope is equal to, it is M is equal to R naught into alpha. So this is the graph we are taking for conductor. Now the question is arising here, what will be the graph for semiconductor? Yes, we will take in a class now here. Now for semiconductor, here for semiconductor alpha is negative. Now the equation we can take here, delta R is equal to R naught into alpha into delta T. in which alpha is not positive, alpha is negative. So what will be the equation here? Delta R is equal to, it is R naught into minus alpha into delta T. Alpha positive for conductor, alpha negative for semiconductor. So the value of delta R is equal to minus R naught into alpha into delta T. So this is a straight line equation coming on the board now. What is delta R is equal to RT minus R naught. Change in resistance is always final minus initial. Final resistance is at T degree Celsius minus initial resistance at 0 degree Celsius, and it is equal to minus R naught into alpha into change in temperature is T minus 0. So it is T minus 0. Now simplify the relation. What is coming relation? RT is equal to R naught minus R naught alpha into T. RT is equal to R naught minus R naught alpha into T. Or this equation we can write RT is equal to R naught plus it is minus R naught alpha into T. So this equation we are writing in this term now, and now we can compare this equation with the equation of a straight line y is equal to c plus mx. Y is equal to c plus mx. Yes, if it is the equation of a straight line, is also the equation of a straight line. Now, comparing both relations here, after comparing, it is clear here in a graph, RT should be along y-axis. RT should be along y-axis, and this small t should be along x-axis. Small t is along x-axis. So we can take a graph now here. This will be the graph in between y versus x. In between y versus x. Here y means RT, y means RT, and x means small t, x means small t. RT is along y axis and small t is along x axis. Now again question arises here, how to draw the straight line by the similar concept as we have discussed many times in a class here. By putting x is equal to 0, you may get the value of y, and by putting y is equal to 0, get the value of x. Here x means small t, here y means RT. So put t0, get the value of RT, put RT0, get the value of small t. So we can take it now here. If RT is equal to 0, if RT is equal to 0, if RT is equal to 0, the value of t will be equal to 1 by alpha. T will be equal to 1 by alpha. Previously it was minus 1 by alpha, but here after simplification you will get 1 by alpha. Another here, if t is equal to 0, if t is equal to 0, the value of RT will come equal to R naught. RT will come equal to R naught, which is non-zero, which is non-zero. So if t is equal to 0, RT is equal to R naught, which is non-zero. Now, these data will now be helpful to draw the straight line as you know it here. Tell me now, if RT is equal to 0, RT is equal to 0, the value of t is equal to 1 by alpha. Yes, t is equal to 1 by alpha will be here, is a positive value of t is 1 by alpha. Now another, if t is equal to 0, if t is equal to 0, RT will become equal to R naught. So RT will become equal to R naught here. So this is the value of RT is equal to R naught. RT is equal to R naught. Now again picture is clear here. Picture is clear now here. What will be the straight line? Yes, this will be the straight line passing through positive x-axis and positive y-axis. So we can take the straight line. This straight line is passing through positive x-axis and positive y-axis. And what will be the straight line equation? This here is the equation of a straight line. This is the equation of a straight line we are taking on the board now. What is the value of the slope? Slope is equal to minus R naught alpha. So the value of slope is equal to minus R naught alpha, and this slope is not positive, this slope is negative. So we are taking this graph for semiconductor, for semiconductor. Okay, for large change in temperature or for the non-linear range, you know it here, when change in temperature is large, change in length will also be large, and if change in length is large, will not be linear, will be non-linear in shape, and this shape may be parabolic. So for the large change in temperature means for the non-linear range. Now one relation everybody know in a class here, RT is equal to R naught plus R naught into alpha into T. RT is equal to R naught plus R naught alpha into T. It up to this here is for linear range. It is for linear range, but here it is not linear, it is non-linear. It is not a straight line, it is a parabolic. So it is converting into parabolic shape, only whenever here it is R naught into beta into T square. So plus R naught into beta into T square. Don't be confused here. Up to this here there is a straight line. Expansion will be one dimensional. But here it is not expansion one dimensional. Here expansion is two dimensional. One expansion in x, one expansion in y direction. That is the reason we are using beta. What we are using? Beta. Beta is the coefficient of superficial expansion. It is for a two-dimensional expansion. Now this equation we can compare with the equation of parabola. Y is equal to a plus bx plus cx square. Y is equal to a plus bx plus cx square. Comparing both relations now. Comparing both relations. After comparing both relations, it is clear here RT should be along y-axis in a graph. RT should be along y-axis and T should be along x-axis. And yes, shape will not be linear, shape will be non-linear. Yes, there will not be a straight line, there will be parabolic. But how it is parabolic, we will take in a class now here. Yes, graph we can take it now. Yes, graph will be in between RT versus T. RT is along y-axis and small t is along x-axis. And the shape will not be straight line, shape will be parabolic. There are two type of parabolas are possible here. Yes, roughly I want to take the diagram on the board now. Yes, it is small t, it is RT versus small t. And one more roughly diagram we can take it here. RT is along y-axis and small t is along x-axis. These are the roughly diagram we have taken in a class, because before taking the actual diagram here, some doubt should be correct in a class before taking the right diagram on the board here. Yes, listen now here. If t is equal to 0, RT will become equal to R naught. So if t is equal to 0, RT will become equal to R naught, and this value will be non-zero. Non-zero. So if t is equal to 0, RT is equal to R naught is non-zero. So tell me now, T0, RT is equal to R naught here. T is equal to 0, RT is equal to R naught. In the same way, here T is equal to 0, RT is equal to R naught. Yes, listen now. Yes, this parabola will be here. Is one parabola this, one more parabola we can take this now. So actually we have taken two diagrams on the board now here. This is parabolic in shape, it is also parabolic in shape. But again question arises here, which one of them is the valid parabola for this equation? Which one is the valid parabola for this equation here? Is it first or is it second? How to decide it now here? Simple. We can decide here by drawing tangent on the curve. Why we are drawing tangent on the curve? So that we can find out the slope. So whenever we have to find out the slope, we can draw the tangent. So we are drawing a tangent here now. One tangent, it will give the angle theta 1. This will give the angle theta 1. Here is one more tangent, it will give the angle theta 2. Everybody know it here. Theta 2 is more than theta 1. Theta 2 is more than theta 1. It means tan theta 2 is more than tan theta 1. So slope is increasing. Slope is increasing. Now in this diagram, yes, again we can draw the tangent. We can draw the tangent on the curve. So this is one tangent we are taking now here. It will give the value of angle theta 1. One more tangent we can take here. It will give the angle theta 2. Yes, theta 2 is less than theta 1. Theta 2 is less than theta 1 means tan theta 2 is less than tan theta 1. It means slope is decreasing. Slope is decreasing. Now the things are clear. Things are clear. Here theta 2 is more than theta 1. So tan theta 2 is more than tan theta 1. Here slope is increasing. But here theta 2 is less than theta 1. Tan theta 2 is less than tan theta 1. So here slope is decreasing. Here slope increases. Here slope decreases. Now in this relation. Here is B is equal to R naught alpha. B is equal to R naught alpha. Another here C is equal to R naught beta. C is equal to R naught beta. Beta is equal to 2 alpha. Beta is equal to 2 alpha. So this R naught beta is more than R naught alpha. R naught beta is more than R naught alpha. It is one slope, it is another slope. So with respect to this slope is increasing. With respect to this slope is increasing. So here slope is R naught alpha. Here slope is R naught beta. So slope is increasing. Here also slope is increasing, and here slope is decreasing. So this is not the right diagram. Is the right diagram. Is the right diagram. Even both are parabola. Both are parabola. But our right diagram will be first, will not be second. So take the value here. If t is equal to 0, t is equal to 0, RT will be equal to R naught. So here RT will be equal to R naught, and this R naught will be non-zero. Yes, this will be parabolic in shape. This will be parabolic in shape. So it must be clear here what we are discussing for large change in temperature or for the non-linear range. Large change in temperature means large change in length, and large change in length will not be linear, will be non-linear. The shape may be parabolic. Shape may be parabolic. Okay, now we can discuss few questions related to the resistance thermometer. Is first question now. The resistance of a resistance thermometer has values 6.74 and 7.74 ohm at 0 degree Celsius and 100 degree Celsius. What is the resistance at 50 degree Celsius? So we have to find out what will be the resistance when temperature is 50 degree Celsius. Okay, you know here one relation I discussed in a class here. This RT is equal to R naught into 1 plus alpha into T. RT is equal to R naught into 1 plus alpha into T. You know, T is the change in temperature. T is the change in temperature. It is T minus 0. T minus 0. So RT is equal to R naught 1 plus alpha into T. That relation will be helpful to solve all type of equation of a resistance thermometer. There is no need to learn any mathematical relation, any other mathematical relation for solving the numericals here. All type of a numerical of a resistance thermometer will be solved with the help of that relation. We will discuss number of questions in a class here. So RT is equal to R naught 1 plus alpha into T. Now here RT means resistance at 100 degrees Celsius. Resistance at 100 degrees Celsius is equal to resistance at 0 degrees Celsius into 1 plus alpha into what is change in temperature is T minus 0 is T. Here 100 minus 0 is 100. So this is the change in temperature is 100. So R100 is equal to R naught 1 plus alpha into 100. Now another here, R50, resistance at 50 degrees Celsius. Resistance at 50 degree Celsius is equal to resistance at 0 degree Celsius into 1 plus alpha into what is change in temperature is 50 minus 0 is 50. So both relations we are developing from here, and that relation we already discussed in a class here. So resistance at 100 degrees Celsius is equal to this, resistance at 50 degrees Celsius is equal to this. Now we have to find out what we have required, then what is the resistance at 50 degrees Celsius. So we have to find out the resistance at 50 degrees Celsius. R50 is required. What we have required? R50. You know here R naught is given. R naught is given, R100 is given, but alpha is unknown value. Alpha is not given. So our motto here to first eliminate alpha. To first eliminate alpha because alpha is not given. First we will eliminate alpha. How to eliminate alpha? By solving these two relations. By solving these two relations. So first we will solve these two relations for eliminating the value of alpha. For eliminating the value of alpha. So what we can write this relation now here? R100 is equal to R naught. R100 is equal to R naught plus R naught into alpha into 100. R100 is equal to R naught plus R naught alpha into 100 multiplying inside it by R naught, or this will come R100 minus R naught is equal to R naught into alpha into 100. This one is coming now. You can take as a relation number 1. Okay, now we can simplify the lower relation. Yes, it is R50 is equal to R naught. R50 is equal to R naught plus R naught into alpha into 50. So, multiplying inside it by R naught. So, R50, yes, minus R naught is equal to R naught alpha into 50. This is taken as relation number 2. Now solving these two relations for eliminating the value of alpha. How to eliminate the value of alpha? By dividing these two relations. So suppose we are dividing these two relations, 1 divided by 2. Yes, it is R100 minus R naught divided by R50 minus R naught is equal to R naught into alpha into 100 divided by it is R naught into alpha into 50. Now it is clear here, this R naught will be cancelled, alpha will also cancel. Now relation will now become here. So R100 minus R naught divided by R50 minus R naught is equal to, yes, it is 100 divided by 50. So this is equal to coming 1 by 2. Now we can put the values here. Resistance at 100 degrees Celsius is 7.74. Resistance at 0 degrees Celsius is 6.74 divided by resistance at 50 degrees Celsius is the unknown value which we have to require it now. So R50 is required minus resistance at 0 degrees Celsius is 6.74 and it is equal to 1 by 2. So after solving this relation, you will get the value of resistance at 50 degree Celsius and it is equal to 7.24 ohm. 7.24 ohm. Okay, now next question. The temperature coefficient of a resistance of a wire is 0.00125 per degree Celsius. At 300 Kelvin, its resistance is given 1 ohm. Then the resistance of the wire will be 2 ohm at, means temperature is required. Yes, resistance will be 2 ohm at what temperature? At what temperature its resistance will be 2 ohm. Okay, as I told you in a class, only one relation will be helpful to solve all type of numericals of a resistance thermometer, and that relation is RT is equal to R naught into 1 plus alpha into T. Yes, keep in our mind, T is not the temperature, T is the change in temperature. What is T? Is the change in temperature. So this relation will now be helpful to solve our question. But how it is? Yes, I want to take in a class here. RT is equal to R naught 1 plus alpha into T. You know, RT means resistance at T degree Celsius. Resistance is at T degree Celsius. You can take resistance at 300 Kelvin, but this T is not the temperature in Kelvin. This is the temperature in degree Celsius. This is the temperature in degree Celsius. So R27 resistance at 27 degrees Celsius or resistance at 300 Kelvin, same part here, but here T is not taking in terms of Kelvin, small t is taking in terms of degree Celsius. So RT means R27 resistance at 27 degrees Celsius is equal to resistance at 0 degree Celsius into 1 plus alpha into, yes, what is change in temperature is 27 minus 0 is 27. So that relation is coming on the board now. So R27 is equal to R0 1 plus alpha into 27 is coming relation 1. Another relation we can develop, resistance at T degree Celsius. Resistance is at T degree Celsius is equal to resistance at 0 degree Celsius. It is 1 plus alpha into what is change in temperature is small t. Change in temperature is small t. So these are the two relations we are developing from here. Resistance at 27 degrees Celsius, here resistance at T degrees Celsius, resistance at unknown temperature, resistance at unknown temperature. Now dividing these two relations so that we can eliminate the value of R0. R0 is not given, R0 is not given, so we can eliminate R0 first by dividing these two relations. So is a relation number 1 is as a relation number 2. So dividing these two relations, suppose 1 divided by 2 here. Now dividing 1 by 2, it is R27 divided by RT, and this is equal to R0 into 1 plus, it is 27 alpha, 1 plus 27 alpha divided by, it is R0 into 1 plus, it is alpha T, it is alpha T. Now dividing these two relations, it is clear R0 will be cancelled. R0 will be cancelled. Now if R0 cancel, a relation will come here, R27 divided by RT is equal to 1 plus 27 alpha divided by 1 plus alpha into T. Alpha into T. Now resistance at 27 degrees Celsius. This is the resistance at 300 Kelvin. Yes, 300 Kelvin means 27 degrees Celsius. So resistance at 27 degrees Celsius is 1 ohm divided by resistance at unknown temperature is 2 ohm is equal to 1 plus 27 alpha divided by 1 plus alpha into T. Now many of the students, they may do mistake here by putting the value of alpha. They are making itself complicated part here. They are making itself complicated relation. So don't put the value of alpha right now. Alpha having a very small value. This value we will put in the last here. So multiplying cross multiplication, 1 plus alpha T is equal to yes 2 plus 54 alpha. 2 plus 54 alpha. Now 1 plus 54 alpha is equal to alpha T, or the value of T is equal to 1 by alpha plus 54. Now put the value of alpha here. Put the value of alpha now here. T is equal to 1 by E. Yes, alpha is 0.00125 plus 54 plus 54. After solving this, T will come 854 degrees Celsius. 854 degree Celsius. Yes, we can convert into Kelvin also. We can convert into Kelvin also. T will become equal to T plus 273, or this T is equal to 854 plus 273, or capital T will come 1127 Kelvin. So the value of capital T is coming 1127 Kelvin. So at temperature 1127 Kelvin, resistance of the wire will be 2 ohm. Will be 2 ohm.